we're all data scientists and business analytics out here, but I come from the world of programming. Okay, I'm a programmer. For the nearly 18, 20 years, I've done all kinds of programming, and even today, I still love writing programs. The earlier presentation you saw was the last mile disconnect. Some of you may have been here, okay? Last mile disconnect. I'll talk about the first mile disconnect, okay, it's the other end. As you see, my presentation will be, quite basic. You'll see lots of codes on the screen. A lot of people today are, scared of codes. Everything has to be drag and drop, okay? Unfortunately, I'm a coder, so code is the first thing which comes to me. And as I said, my data science work comes from two sources. As I said, I'm a programmer, and I also happen to be a DBA, RDBMS, okay, long back. And so, the four pieces of data science, technology, mathematics, business, and visualization, I kind of operate at the technology end. However, having done a PhD in operations research, I'm not shy of mathematics, though it's not my primary area. So when push comes to shove, I can roll up my sleeves and do mathematics as well. Visualization is something that I am not very great at, though I still try. And business is something I'm forced to understand, because in the consulting business, unless you can get clients, your technology goes nowhere. Somebody has to pay for your technology. Hence, I have had, in the consulting business, I have had to talk to a lot of clients. And which is the reason I came out with this presentation today. Because about 3 years back, when I was teaching at IIT Kharagpur, I was a faculty there at that point in time, I heard of the elephant called Hadoop. And of course, we had to be at the edge of things. So after a lot of struggle, I got the elephant into my machine. And any of you who have installed Hadoop would know that that's a fairly long process and painful process with hardly any support from anybody else around you. Of course, today with the Hortonworks and all distributions and virtual boxes, you can get Hadoop up and going with one click. But 3 years back, my God, it was a titanic struggle to get Hadoop going. Fine, so I got Hadoop going. And then I said, let's see. Every programmer has heard of Hello World, right? So I got the Hello World program. There's no Hello World in Hadoop. There's something called word count, okay? So I dutifully ran my first Java program in word count, said, yay, I got it going. Then I said, well, what else can we do? I ran a Python program in Hadoop, Hello World, word count, damn. Looked around. I did R, I did Python. I was counting more and more words, okay? So let's find something else. I mean, other than word count, what on earth do people do? Then I realized Hadoop has come from the world of counting, and all their search engines and how many links and this and that. So for Yahoo and Google and everybody, counting of words is their basic business. But to go and try to explain it to ITC, go to Spencer, why should they count words? I said, look, let me look around a little bit more. Must be something somewhere. So I did for nearly a lot of time. I found out that everywhere I went to do some kind of a program, ended up doing word count. So then I wrote up to a few people, and one gentleman, not a very known friend, but he was doing in Hadoop. He says, look, brother, of all the programs in the internet, he has done an intensive scan. 50% of the programs, Hadoop programs in the internet, count words. Another 25% count sentences. Another 24% are about sorting files. So, and none of these are related to any kind of a business activity which normal corporates do. So that's when I started thinking there has to be a way to do something useful with it, because I could say Hadoop is a terrific product. I mean, if you look at it, I mean, the concept, what a product. I mean, the kind of things Hadoop does is unimaginable. So that's the genesis of my story. I said, look, okay, let us try to map it to something which has a practical relevance. And since I'm in the world of data science, let me try to map it to something that we teach in our statistics and machine learning classes and see how Hadoop can be used. I don't know if any of you have used Hadoop otherwise, but for me, it was quite a challenge to get it down into this format. And you'll realize that there is significant amount of gymnastics you have to do to convert a normal practical problem to actually work with Hadoop and deliver the kind of things which Hadoop does. Okay? It is not simple. Now you will tell me there is this animal called Hive and this animal called Pig. Some of you might have used it. Hive, brilliant. With Hive, you can forget Hadoop and think of it as a gigantic SQL engine. The Hive query language, HQL, is 99 or 98% similar to SQL. And I'm sure all of you here are SQL jockeys, right? Coders. SQL is like the universal language in the internet or anywhere in the IT world. But then I was wondering, if I have to Hive and HQL, then what's wrong with our SQL? I'm a DBA. I've been doing SQL for years, and we have gigantic databases which can crunch through 1 million rows. I mean, for a big database, 1 million rows of data is not a challenge. If you look at SQL, so Hive is not really the real operating value for Hadoop. It's good to get. Okay. So then I said, let me, as I said, map it down to some kind of a statistical and operation. And then I came across this problem. You see, if you look at a business requirement, we have a retail business store, and actually this is one of our clients, so we talked about this, and they never went the Hadoop way finally, but idea was born out of this. You have data on SKU. SKU is what you stock in the store, retail stores. If you go to Spencer or Big Bazaar, you'll find about 30, 40, 50,000 SKUs. Soap, salt, sugar, this, that, all kinds of things are there. And you have data for sales, because each time you check out at a counter, whether whatever happens, on the point of sales record, you have that how much sugar was bought, how much salt was bought, and comes out. So the data is there, very much data is there. Now the idea is, if you have data for the last 30 days, can you predict the sales for the next 10 days? Now there are lots and lots of issues regarding prediction of sales data. But when we work with mathematics, we work with abstractions. There are seasonal data and this and that, all kinds. But to begin with, we can predict a future using regression. I mean, it's a simple tool. It's one of the most widely used tools. In any university you go to, anywhere you go to, regression is the cornerstone of all activity. And it's predictive. So it fits in with our worldview of data science, has to be predictive, not descriptive. So it's a good thing. Okay? So we thought that could we use the past data to predict the sales of a particular SKU so that the ordering cycle can be arranged later on. Okay? So this is the problem that we wanted to address. A quick answer, many of you would be heard of regression, but this is a quick analysis of what regression does. For those of you who have forgotten what is regression, okay? If you have a set of numbers called x1, x2, x3, xn, and y1 through yn, we are looking for an equation which relates x to y, given y is equal to a plus bx. And your job is to find a and b. Okay? And if you know a and b, then given a value of xp, you can predict a value of yp. The mathematics behind this is, I think, 300 years old. Okay? So it's very well understood. There is no ambiguity about it. We all know what are its limitations. We all know how it is good for. So it can be used. So this is regression. And we'll see how this can be working with Hadoop. But first look at the challenges. Okay, our daily sales data is available in a file. And the file goes like this. On day 1, we sold 90 units of soap, 90 units of salt, and 120 units of soda. Example. Of course, there will be more granular stuff will be there in actual. I'm giving it simple. Okay? And this goes all the way down for about 50,000 records. Fine? This is the data. But this is 1 day's data. The actual data we have to look at is perhaps 60 days of data like this. Okay? So we have 60 such files, each for 1 day. And on this, we need to carry out the regression. Okay? That is a challenge. Now, do you basically the same thing. Time series, regression, they're all close cousins of each other. Yeah, we could have certainly. I mean, time series is we have some auto-correlation and all that. But basically, I'm keeping things simple. If you can do this, you will be able to do time series also. Okay, I mean, you can replace the regression model with another more complicated model also. But I'm keeping things very simple. Yeah, you need the time series. Okay. Okay, so now this is the problem. You would think this is an easy problem. What's the challenge? I have the data, Maro regression. You have a problem. Okay, the problem lies is the data is lying in this form. Each file is like this. But the regression has to run across the horizontal. Because you are predicting soap on day 70, which means the data has to be extracted from each file and a lot of things has to happen. So if you had one file, you could have applied R onto it straight. Import CSV, run regression, out of the answer. But here, the data is lying in 60 files. So you have to, for each file, you have to read the file, go sort it down, find it, and come back to it. It's a challenge. Okay? So this is challenge number 1. There are 3 challenges. Challenge number 1 is getting the data from all the files. Challenge number 2 is this has to be repeated 50,000 times because there are 50 SKUs and each regression is separate. Okay? Problem number 2. So problems get compounded. Okay? And the third problem is every day the data window moves. So what you did yesterday cannot be used again today because you need to throw away the 60 days old data and bring in another day's worth of data and then continue. Okay? So there are, so you are not done. It is not a one-time effort. So every night before when the store closes or whenever, you have to do the entire thing once and get it ready by the next opening window. So this is where the challenge lies. How to make Hadoop bring in here, how to bring in Hadoop out here to try to address the problem. But before Hadoop, let us try to address the problem from a programming perspective. Let us see. And here, friends, if you are not a programmer, please bear with me. I'm going to throw some codes at you. Okay. So please don't. This is not a pure PowerPoint stuff. This is actual coding, and the codes will be available to you later on also. So every night, or somewhere in the window, the data files have to be transposed. The data from soap data has to be acquired from, this is like a huge matrix has to be turned around like this. Okay. And then the regressions have to be performed. Okay. And this is where you have to think through. This is where you cannot say, I have Hadoop, solve the problem. You have to restructure the problem in a manner that it can actually work with Hadoop. Otherwise, having a 10,000 cluster Hadoop will also not solve your problem. Because if you take a regression and throw it into Hadoop straight away, well, Hadoop will treat it as one large problem and use a single CPU and single processor and do it. And the other 99 processors will sit idle. Nothing will happen to it. Because Hadoop would not know how to ship it to the other 99. And this is where your ingenuity as a programmer as well as a mathematician will come into the fore to make it happen so that we can use these two powerful technologies together. Okay. So here we are. We have two technologies. We have R. The R is finally, of course, in my opinion, the last word in data science as far as algorithms goes. We can debate with SAS, SPSS, Python. That's another debate somewhere else. For the time being, because R allows me to do both the regression model and the prediction with only one line of code. One line of code, that's all. M is equal to LM, Y, X, that will give you the model. Provided you get the Y and X correctly in there. And YP is predict, that's all. I mean, if you're familiar with R, you'll recognize that's all the code required to solve a regression problem. 2 lines of code. And we need to use Hadoop to kind of speed up operations. So let us see how will we do this. Okay. The code that I'm talking about out here is all available in GitHub. So don't need to write down the code. You can always download it whenever you want. And at the end of the slide deck, you'll also find the GitHub URLs. Okay. So we have these 5 files like this. These 5 files have to be kind of turned around like this. Okay. Not only turned around, they are being rearranged if you notice. We need to extract a key and a value from each data because Hadoop, the only thing the elephant understands is a key and a value. Nothing else. So you have to feed the elephant only keys and values. So you have to now massage your data and put it into the key value format. In our case, the key happens to be the name of the SKU, and the value happens to be a character string, of which the first part before the separator is the date, and the second part is the value, is the sale quantity. So this can be done with any language can do it. Done it in R, just read it, rearrange it, and put it back. Okay, just input reader, turn it around, and this is happening at a file record level, so happens reasonably well. This is the first part. Then you have, anybody who has done Hadoop will know something called a shuffle sort. Okay, so the data which was like this has to be put in this form. This is called the shuffle and the sort part of Hadoop. You don't need Hadoop to do all this, but you need the sorting has to happen. And finally, on each of this data, you have to run a small regression. Okay, regression. I'll say small, why? Because it's only 60 rows of data. 60 days, 60 pieces of data, which is an easy matter. So here we have written out a small R function called estimate value, okay, which is, as you can realize, it's only 2 effective rows of data coding is there. Rest is just unpacking the data from a string and packing it back and input-output kind of trivial operations. The main things are those 2, building the model and estimating it. So with this, with R, I can solve the problem. Okay, I have not yet brought in Hadoop. So now let us see how this works. And why did I choose R? Because as I said, that is a language I was comfortable with. I could have done this with Python also. Python has similar features. I could have done this with C and Java. Java, I would have stayed away because I'm not a Java person. I'm looking at my color of my hair, you'll realize I was before the Java age. So I'm a little bit of, public substatic void and all it kinds of gives me the creeps. Okay, so I was sticking to R. And here you see this line that you see on top is the kind of solution to your problem. The first is the cat, it's all Unix. So it dumps the data into the first program, which is in my case is called the mapper program. The mapper program kind of transforms the data from here from a slightly way. Then you have the sort, which is a simple Unix sort, okay, which sorts the data according to the keys. And then you have the reducer program. And when it runs, you will see the answer will come out straight away that estimation for SOAP on day 9 is 222. I had only 5 days of data and predicting on the 9th day. Okay, in my case, it's a toy problem actually. Okay, you can extend that to 60 days of data and whatever. Okay? So the answer comes. So estimated sale of soap on day 9 is 222. Great. So we have got the structure of the problem. We have got the problem. It is now defined in terms of a map step, reduce step, We have defined it in terms of keys and values. Hence, this problem can be thrown at Hadoop. Okay? Now we can bring in the power of Hadoop. Okay. So the only way, so you see this problem I solved on my laptop. I mean, it's a 2-minute problem to solve on your laptop. Okay. Now we'll see how to parallelize it. Now, of course, on a laptop we have Hadoop installed. It's a single node cluster. Obviously, if you're going for a truly large scale problem, this will not solve the problem, but this will help us understand how Hadoop will address the problem. Because once it solves on a single node cluster, it will solve on a 10,000 node cluster also without any change. Okay? Only the configuration has to be changed for installing the code. So now we see we have ways of parallelizing it. And for those of you who are not very familiar with Hadoop, Hadoop works in this form. We have a main name node, and we have a couple of data nodes. The main node is the master. The data nodes are the slaves, which are controlled. Within Hadoop, there are two important aspects of Hadoop. One is the file system, where the data is stored, and the other is the MapReduce engine, also called Yarn these days, Yarn. Okay. Now the point is, the Hadoop file system is different from the file system which exists on your Unix machine. In a normal Unix machine, you can do cd, change directory, and reach the proper directory and read the files. In Hadoop, you can't do that, because Hadoop will split the data across multiple machines, and you can't really view the files individually. You have to go through the HDFS file browser, and then you can see the files. When you go through the HDFS file browser, you will see the files in the familiar directory structure, but if you go into your own machine, you will not find those directories anywhere. Okay? They are not there. So, and Hadoop will only work with the HDFS file system. It will not work with your local file system. Secondly, the MapReduce part is where the program is distributed across multiple machines. So wherever the program finds the data, it will work on that data. So it can work on a distributed data very easily. And the nice part of it is, once it is inside Hadoop, it is totally transparent to me. Now, transparency is a bad word. Okay? It's a word used by salesmen when they try to sell, complicated software to other people. Nothing in this world is transparent. Nothing in this world is interoperable. Somebody will do the bulwark of making it transparent and interoperable. But by and large, for a person like me who had never configured, who had never had the luxury of working with multiple servers and all, Hadoop, is reasonably easy to configure. Of course, depends on what you mean by reasonable. Okay, some people think a single click is reasonable. Some people think XML files are reasonable. Anyway, so this is the structure that we have, and we have these data nodes. And on my machine, we have configured a single data node and a single name node, both landing on the same CPU all together. Okay, so this is the basic structure. And then we have the famous Hadoop Streaming API. Now, as you would be knowing that, Hadoop is primarily a Java product. So it was built in Java, meant for Java programmers and stuff like that. So if you have to run a MapReduce program, you have to write a Java, code, make it into a jar file, and run it. Okay, that's how you run a Hadoop program. But unfortunately, many of us we are kind of phobic about Java, Java phobes, Java phils. Okay, so we look for other ways of kind of avoiding Java, and thankfully the Hadoop crowd understands that, and hence they have given us this wonderful thing called the Streaming Java API, Hadoop API, which is just a jar file. Okay, now with this Hadoop streaming jar file, you can run a program in any language. Okay, R program, Python program, C program, shell program, Unix shell. I don't know whether a batch program will run in Windows, but I've never seen Hadoop on Windows as yet. Okay, but you name anything which executes, on your machine, you can put it in there. So and the command is very simple. It has 4 parameters. One parameter is what is your mapper program, what is your reducer program, where is the input data, and where should the output data go to. 4 parameters are required. You have to specify that. Say Hadoop jar, Hadoop streaming jar. That is you have to locate that jar file in your Hadoop installation. It will be hidden deep inside, and you'll see shortly how deep it is hidden inside. Okay, to really hunt it up. Mapper, the map program, reducer, reduce program, input and output. And these input and output file directories are in HDFS. So they have to be on HDFS. Now, once this is in place, what I'll do is I've written those 2 R programs for doing all that. I will now plug in those same R programs into this Hadoop. Nothing will change. The R program which I wrote, it was giving me the answer, the 2 R programs, and Hadoop will also give me the same answer. Okay? This is how it works. Okay. First, you need to create a HDFS directory on top. The DFS is the distributed file system. These are commands. Then you have the HDFS, DFS, copy from local, which means copy from the local directory, throw it into the HDFS directory. Then you call the Hadoop streaming jar. That is the which I simplified the command earlier. This is the actual command. Here you will find the huge, where it is located, user, local, Hadoop, share, Hadoop tools, lib, Hadoop streaming. As I said, hidden deep inside the Hadoop infrastructure somewhere. And then you have to specify all that. So the answer comes out in an HDFS file. You have to get that answer from the HDFS file into your local file system, okay, which is a file called result. And the result, then I just print it out on the screen, and you'll realize the same answer has come out. Okay? So whatever answer I got using without Hadoop, I have now got using Hadoop. Okay? But the difference is now, if this problem was large, and if I had a multi-user, multi-machine cluster, the problem would have been run in a parallel mode instead of running on a single mode, and hence it will be considerably faster. So now I have got it done. It's not the time, right? Okay. Not, okay. So this is the R with Hadoop. Now, so we have got R and Hadoop going. Now the other problem is, you see, all this is very messy, Unix type stuff. Long commands have to be written and all that. A lot of people don't like this. A lot of our data scientists prefer to work in the cool comfort of R. Okay, so there you are, sitting with the RStudio IDE. Okay, now I don't want all that messy Unix stuff. That you leave it to the Hadoop jockeys. Let them write it. I am only work with R. Now, fine, not a problem. There are 2 options available using RHype and RHadoop. Now, RHype is something that I have not used, so I will not tell you anything about it. RHadoop is, you can look at my blogs. I have been struggling with RHadoop for nearly a year and a half, and I finally got it going because RHadoop is quite a, challenge. But once it's going, it's brilliant. What happens now is, instead of 2 separate programs and all that, everything can be written inside one simple R program. Okay. You would notice it is almost the same as the last R program that I wrote. The estimate value function is identical because that is where the regression is happening, so not a line of change. Okay. The mapper function is almost identical. I just simply improved a little bit. I mean, but basically it's the same thing. It's just now a small function. So instead of separate programs, you have separate functions being called from the R environment. And of course, the reducer function has become much simpler because for a very interesting reason, when I didn't have Hadoop, all the key values were bunched and given to me in one shot. So I had to actually look through the keys, find out when the key has changed, and then call the regression. In this case, Hadoop will give it to me already, partitioned in chunk bits. So this is for soda, this is for salt, this is for soap. So I don't have to do all that little bit of playing around with checking when the key has changed and all that. So it becomes quite easier. Okay. And then of course, those three functions are there. You need to set up the basic environment within Hadoop to tell R where the Hadoop libraries are, where the streaming libraries are, and all that. And then finally, you get one function. The entire call to Hadoop is reduced to one function called the MapReduce function. And you'll see this MapReduce is nothing but calling the streaming Hadoop API. Here also you'll see where is the input, where is the output, where is the mapper, where is the reducer. So with this, everything becomes one small R program. And even the I/O from the normal file system to the HDFS and back is again done through R functions now. And those R functions come from those two libraries, RMR2 and RHDFS. These are two libraries which are available with R, which allows you to do the file operations also here. So with now, if we run this, and you'll see the answer will come out, and again the answer will be the same. So whatever answer we got without Hadoop, what we got with Hadoop and R, and what we got with R Hadoop, the three answers are identical. Okay, which means our ecosystem is now complete and it works and it is ready for scaling up. And with this, we are now in a position to address the problem of predicting retail sales. Okay, so this was the main idea behind me, because that's what I teach in my class. So I have to teach in the class unless I'm convinced myself. I don't feel like teaching things in the hawa. You can have a Hadoop presentation with only PPTs. Name node, data node, this, that, and all this and that, and a word count program. Now that's fine, but for a student who has to go out and face a business problem, they'll be stuck with word count. So that is the reason we did all this for our class. Huh? See, I cannot estimate that because I am running it on a single node cluster. In fact, with Hadoop, it takes a much longer time because the Hadoop overhead comes in out here. But if you do it here, Hadoop will scale it up dramatically. I think there is no comparison between what you can do with a single node and what you can do with a multiple node. But honestly, I don't have of course, on this one single machine. I don't have any big data also for this. But just wanted to bring it down to see whether this approach can be used. Okay? And just for that matter, the reduce function is greatly simplified, and you can look at the code and find out how it's getting simplified. Now the next question is, one of the challenges in science is to go from specifics to the general. Can you now extend this to a more generic case? Retail sales is fine, we have got regression, but let us look at another problem. Okay. Given a set of numbers again, x through and y, we did a simple linear regression. Y is equal to a plus bx. But there can be many other models possible. A plus bx square, ax plus bx square plus cx cube, and so on and so forth. Can we apply it there? And secondly, in regression, can we have, say, 100 million records, 100 million data points? Can we apply the same technique that we use out here? So this was my next challenge, how to go from the very specific case of a retail sales to a more generic case. And here, maybe things like times, all of them can be brought in out, because effectively we are doing the same thing. You replace the LM module with a TM module, that's all, will change. Okay. So what I did was, again, I don't have the luxury of working with truly large data because I don't have that kind of infrastructure myself. This is a very simple data that we have about predicting website visitors. So we got this data from somewhere. We have 743 data points. Again, so for 743, you don't need Hadoop. You can do it jolly well with R. Okay. But anyway, we were looking at two predictions. Is there a way you can predict the number of data points using either the linear or the quadratic function? The linear function is the blue line, the quadratic function is red line. Okay. This can, as I said, it's a trivial problem in R to get this. If you have the data, you just throw it in, and those two, you say instead of a linear model, hits and hits and hour, and I want a polynomial function of order 1 and a polynomial function of order 2. You can go to 3, 4, 5, 100, 200 if you want. I mean, just makes the graph more, wiggly. Okay. It depends on what kind of data you have. Okay. Nothing, because in this data is so messed up. Nothing, no prediction will work. This is actually very bad data. Okay, so that's another challenge by itself to figure out which is the best model. That's a separate problem by itself.
So we can use this kind of infrastructure for the identifying which model.
Right. That's right. You can try out various and find out which one.
Like parallelizing using the
Parabola, quadratic, cubic. So many things can happen to this. Okay. As I said, you can go get any kind of mathematics order equation out of this one. R will allow you to do it. But our challenge is different. Our challenge is to make it work with Hadoop. Okay? Equation is fine. I'm focusing more on the Hadoop side. So here what we do is we do exactly what we did in the last problem. There we had a natural key, which was the SKU, soda, salt, and all this. So here I have taken I don't have I just one piece of data. So what I do is I just partition the data, okay, into 20 slices. I give an arbitrary identification that this data is from piece 1, this is piece 2, this is piece 3, and this is purely a random. I mean, I just randomly split the data. Every 20th data goes back to the same bucket. The first data is in this bucket, second this, third this, fourth this, fifth this, 20 buckets. So the 21st data goes into the first bucket. So I have now got the data spread across 20 buckets. Now what I can do is I can run a regression on each of those 20 buckets separately. Okay? Now the point is, if I have a full, say 1,000 pieces of data, I run regression and I get a value of an A and a B. Remember, y is equal to A plus bx. I've got a value of A and a B. If I now break it up into 20 buckets, I get 20 values of A, 20 values of B for all of them, isn't it? But this is dangerous. A statistician in this crowd would have howled by now. He says 20 values of A cannot be averaged as the real value of A. It is statistically erroneous. Okay, you can think about it later on, but you'll realize. So solving the problem in 20 parts is not helping me, because I have now, as if I have thrown away the other 90% of the data. So I have got a value of prediction based on 20, one bucket, which is 1/5. Now, assuming all of them are equal random distributions, so the same model should go in each one. I can't have different models for each one. Maybe. Okay. So now the trick is here. What we have is the A and B are called coefficients of the regression. You cannot average the coefficients, but you can average the predictions. That is a statistically correct way of doing things. So from 20 separate regressions, the A and B values will come out, but from these 20, I have 20 predictions. Now I can do a averaging of those predictions, and I can create a confidence interval out of them. So now I am again on strong statistical ground again. And I have the power of Hadoop behind me, which will allow me to break up the problem into 20 separate problems, solve it, and give me back a prediction. Okay? So this is what is happening out here. We basically break it into 20 parts by simply doing a modulo 20 and getting a number, artificially creating that. Okay? Everything else remains the same. The reducer remains the same. The estimation value remains the same. The map reduce remains the same, except in the regression model, I have got a polynomial model now instead of the linear model. And then when I run it, I get 20 values of my prediction. Okay? And on that, I can do a little bit of a statistical manipulation to find out the mean, to find out the standard deviation, and to create the confidence interval, which again is very trivial in R. Finding out mean, standard deviation is a small things in R. So finally, what I've got is I have got values of the predicted number, and I was trying to predict the number of hits on the website on 300 hours at the 300-hour value point, and then I will see that the two are reasonably correct, close to each other. This was the prediction I ran with the simple regression model using R and all 700 pieces of data in one shot. This is the normal way of running a regression. So this is 1343. I do it in my way, breaking it up into 20 problems, solving the 20 separately, and finding the average of them. You will find within the 20 problems a huge variation. Some of it went down to 1166. Some went up to 1554. The predictions were quite widely spread out. But the average, I've got it down to where it really was, is 1345, okay, with a 95% confidence interval. So now I can say that if you do this, you are getting a good answer, a reasonably good answer, provided you have the thing going right. So what have I done? I have now solved the same problem once using simple regression and the other time using Hadoop. Okay. Of course, for 743 pieces of data, I never needed Hadoop. But when that becomes million, 2 million, 3 million, then Hadoop will become very useful, and this programming style will not change. So the idea is to convert my regression approach. I had this tool in my hand. Now with this tool in my hand, I could not fix the problem. So now I've got two tools in my hand, and I know how to make those two tools work together to solve my problem, regression with Hadoop, which can be used not only for retail sales, but for any problem has similar kind of issues, which could be regression, time series, whatever you want. Same approach can be used. Okay, so this is exactly what I had to say, and the conclusion is that we have the various statistical functions available so easily in R, and we have the ability to distribute the load across multiple machines in a Hadoop cluster. And if you happen to club both of these things together, you get what is known as a very good solution for addressing large-scale problems with Hadoop using statistical tools. So that's all I had to say. The slides, this slide deck will be available on these websites. Okay, those are my blogs, and the code is available in my GitHub. And you know more about data science, please visit my blogs. And any questions you may have, I'll be happy to answer. Honestly, I have not got Spark going on my machine as yet, so I don't want to talk about things which I have not practically experienced with. I'm not as I said, unless I've coded things myself, I don't feel confident giving GAN on that. It's about online stuff most probably. For example, Hadoop, one challenge Hadoop is it's basically a batch operation. Whereas, in many cases we find that, the batch operation is not the right way of doing things. So they are looking at other options. So as I said, I don't want to talk about Spark until I know it better.
So one question. So previously you were saying it was used mostly for word count kind of Hadoop. So can you just give an example as to what was the practical application of that?
Oh, no, it was not previously being used. All the examples available on the internet are word count. See, what will happen if you go to Google's PageRank mechanism, their whole theory is based on how many links are pointing to which page. So it's counting the number of inward links, which are actually counting words. Each URL is a word. So their entire PageRank thing was based on counting these URLs, and hence, it was very useful for them to do all this. Now, I'm sure Hadoop is used even otherwise, but because their legacy was from in counting words, so all the sample programs on this planet are from all word count programs, which is very irritating for people like us.
You play with a smaller data set, right? So when it comes to GBs or TBs of data, RStudio from the client perspective will not be able to that scalable because your system will have some limitations based on your RAM. So how will we?
No, that's why we are now, that is the beauty of it, na? Because R will only be moving the data into Hadoop. The R will not get loaded because you see what happens when you say import data into R collapses. Right. But here the data is never coming into R.
It's running on the server. So
R is moving the data from the file system into Hadoop. Then asking Hadoop to solve the problem for me, and then the answer is coming back to, only the result set comes back to R. So the scalability issue is addressed completely. You run on one machine. If you have a 100 machine cluster, you don't see the 100 machine cluster. You see only one machine, which is the node manager. On that you have R running. That's it. And behind it, Hadoop will manage the entire thing. So you think as if you're sitting on this Dell machine and running a 1 billion line regression. It's actually happening somewhere else. I'll not say agree with that notoriously anyway. True, you can use a C program for it. You can go to Java program. You can replace my the R programs, which we are. But that's a matter of debate whether you can write a very complicated linear model with Java is possible. There's nothing. I mean, this is a well-known mathematical concept. You can write the entire thing in Java. Yeah, Python can be used, all of them, as I said, but a lot of people in the world data science are very comfortable with R. So that's why we teach R, and we say that, you can go with R, you can scale up with Hadoop. You had a question. Logistic will work. Clustering has to be thought through again. It's not easy. We are working on it. It is not as easy as this because it's a regressive, recursively called Hadoop, which is, mind bender actually. Logistic regression is straight, no problem. Straight away it will work. You replace my LM with GM, SGM. You can't take an average of the predictions, but then you can find out how many zeros, how many ones. You have to balancing of that. Yeah. In principle, it will work. Clustering, don't ask me as yet. Maybe next year I'll come and tell you. There is a philosophy whether algorithm is more important or the data is more important. I mean, earlier the algorithm was more important. There's an open debate. I cannot say quickly a yes or no on this. It's a big debate. A lot of big people have thrown up this issue, and I don't want to take a quick shot at an answer on this. I don't think so. All of this was based on regression, boss. I mean, and people time series, logistics, all are based on powerful statistical tools. Yes, sir, somebody had a question here.
Hi. We have started doing something on R, and we have the analytics running, but we have not yet turned towards the Hadoop part, and we are fairly ignorant about that. So to start with, very simple. We hear so much versions of Hadoop, like Apache Hadoop and different distributions. Hadoop from Google. What is the right thing to, like, in a simple way to?
Hortonworks. Download the Hortonworks virtual box, and you will get the entire Hadoop configured in one shot. It will not have R in it. You have to install R into it, and that can be quite a struggle, or it may have improved. But R and Hadoop installation. I have a specific blog post on this, on how to get R going with Hadoop. It's not a very simple thing. I had to struggle nearly 6 months to make it work. but I've written it down now. If you follow it, it should work straight away.
Thank you.
Thank you very much. More questions? Pardon? I didn't get you. Scalar.
It's offered by Revolution or for big data.
Possibly. I don't know. I mean, I've not used it, so I'll not talk about it. Well, thank you very much. I think we are done.
The next session